bit about fungal responses. Soil is a very good insulator. So any fungi that are below about 3.5 inches in the soil are not going to be damaged even by a very hot fire. But there are some fungi that we find close to the top of the soil, and some of them are actually activated by fire. So I'm going to talk about 3 of our fungal species: Rhizinia, which is also known as a teapot fungus, that's activated by fire; Armillaria, which causes a root and butt rot in our forest, and it actually has some interactions with other fungi when fire burns. Laminated root rot, Phalinus sulfurescens, also causes a root and butt rot in conifers. And then a little bit about the heart-rotting fungi and the mycorrhizal fungi, which are beneficial fungi on tree roots. So, Rhizinia, I find this really amusing, how it got its common name. So, forest pathologists in the 1800s started noticing this fungus, and where they would see it was where campfires had been. So maybe a crew would come through, have a campfire, and they'd leave, and then Rhizinia would pop up. So this is activated by fire. This is a pathogenic fungus. It's pathogenic on tree seedlings, and after fire, it can be active for a couple of years. So sometimes you will get problems with young seedlings regenerating for the first couple of years after fire, and that can sometimes be caused by this Rhizinia, the teapot fungus. Armillaria astoye. This is a root and butt rotter. It'll get into the roots, and it itself has what are called rhizomorphs, which are not true roots, but root-like structures, so that the fungus can move from one set of tree roots to another. And I actually have a picture there of rhizomorphs. I took that after the Table Mountain fire. So these obviously were killed. They were in the surface of the soil and were killed by the fire. And Armillaria can be killed by fire, but Armillaria also has an interaction with a trichoderma fungus. And trichoderma is pathogenic to Armillaria, and trichoderma is activated by fire. Now, there actually have been some efforts to inoculate soils with trichoderma fungus prior to prescribed burning to try and reduce or eliminate this root and butt rot in the soils. Hasn't been terribly effective, but this is one interaction with fire that occurs and can reduce the amount of Armillaria in a forest stand. That picture on the lower right is just what Armillaria looks like at the surface. So this is the base of an infected Douglas fir. The Douglas fir has attempted to slow the spread of Armillaria by pitching. So the outside of the tree has a tremendous amount of pitch, and then I've chopped into the bark there, and you can see underneath the bark there's this white, looks like white latex underneath, and that is the fungal mycelium, and it's actually feeding on the phloem and the sapwood of the tree. Okay, laminated root rot. This is Phalinus sulfurescens, and this is kind of a bad one to have any place where you have development, because this will often cause a tree to fail before it is dead. So you'll get trees that are still green falling over because they're infected with this particular root and butt rot. But when they fall, they will often fall in this way. They'll pull up the roots. Just as falling can sometimes reduce the amount of fungus in the soil, but when you get a fire in an area with laminated root rot, the fire can then burn into the stumps and into the roots that have been exposed. And so you can get some reduction of laminated root rot from fire in a situation like this. Mycorrhizal fungi, these are really important to trees, particularly young trees that are trying to get established. Mycorrhizal fungi live in the soil, and they will inoculate tree roots. And actually, when you're growing trees in a nursery, most nurseries will inoculate some kind of mycorrhizal fungi on the tree roots because it's so important to the tree. It actually expands the root system of the tree and helps with nutrient uptake. And mycorrhizal fungi can be damaged by a hot fire. They're actually more damaged when fires burn in wet soil than in dry. So a little bit of advantage to our drought prior to fires, less likely to damage the mycorrhizal fungi. So mycorrhizae can survive temperatures of something over 300 degrees in dry soil. But in wet soil, 212 degrees will kill these fungi. So if the fire burns fairly quickly, doesn't have a long residence time, doesn't really cook the soil, you can still retain mycorrhizal fungi. But I think many of us who've looked at a lot of fire, Susan, I'm sure you've seen some of those sites where the soil, we talk about soil being sterilized. This is one of the things we're referring to, is a loss of the mycorrhizae. Just a little bit about the trunk rotting fungi. Aspen in particular, if a mature aspen does survive fire that doesn't kill trees will scar them very often. And those fire scars then provide a court for fungal spores that are in the air. This is just one fungus that is really known to infect aspen. So this is Phalinus tremuli. It causes this kind of butt rot. This butt rot in aspen is used a lot by wildlife as a nesting source, so it's not entirely a bad thing. These kinds of trunk rotting fungi will occur both in deciduous trees and in conifers. They're somewhat less of a problem in conifers because conifers are resinous, and so they have the ability to wall off those rotting fungi to some extent. So now I'm just going to go over the factors that affect the survival of fire-injured trees. Now, I'm going to use some work that was done by Don Scott and his colleagues, Craig Schmidt and Leah Spiegel, in the Blue Mountains. We've been using this Blue Mountains system for some time now. We actually have 5 years of data for the North Cascades, some of which was taken right here in the Mehmel Valley. And I'm really almost daily knocking on the doors of the pathologists and saying we're ready for that to be published now. But one thing we have learned from that is that the fire mortality is usually finished in the first 3 years. There's a little bit of additional fire-related mortality that happens in year 4 and 5. But sort of intuitively, most of the tree killing happens in the first year. Some in the second year, and some in the third. So we really need that whole picture of how long it takes for fire damage to kill a tree. So what Scott and company found was that there are really 10 factors that you can look at to try and evaluate the likelihood of a tree being killed by fire. Now I have brought a few copies of this publication. If anybody wants a hard copy of it, it's online also. But these are the 10 factors, and you'll notice that 6 of them are factors that are in place before the fire burns. And the first one really that we look at is what season did the fire occur? Late season fires are less likely to be lethal than early season fires, and the reason is that trees are more easily damaged when they are actively growing. So if you get a fire in the spring, you will have buds that are still expanding, a lot of tissues that are still growing. By late season, the buds are firm. And now that's not, you can still get trees killed, but they're less likely. Pre-fire tree vigor. Trees that are vigorous can recover from their injuries better. Just like if you're injured, you can recover better if you were vigorous beforehand. If there's downwoody material on the ground, for instance, a lot of dwarf mistletoe brooms, or perhaps, as Susan was mentioning, if there's slash from a previous fire, That then will cause a fire to have a longer residence time. And you can have more damage to roots, you can have more damage to the bole of the tree, to the cambium, and you can just have more convection up into the crown of the tree. Dwarf mistletoe infection, I already talked about. Mistletoe-infected trees are more likely to be killed. Presence of root disease. Again, this is about tree vigor. If a tree already has some weakness from root disease, it's less likely to be able to recover. And then the bark beetle population that's in place at the time the fire occurs. If you already have a high beetle population, and then you have a lot of damaged trees of a species that those beetles are after, they can respond right away. And then what happens to the tree during the fire? The amount of the live crown that is scorched. If the entire live crown is scorched, the tree is highly likely to die. But really, if there's any of the live crown left, there's some possibility that the tree can keep photosynthesizing. How much of the bole circumference is scorched? And that is really a clue for you as you're looking at it. It's how intense the fire was around the tree. And when the bole is scorched, that can heat up the cambium. And you can actually get damage to that cambium underneath the tree. The height of the scorch will also tell you how much of a convection current there was and how hot the crown of the tree got. And then the amount of duff consumption. And trees that are thin-barked, of course, are more likely to be killed by fire than thick bark. I have actually looked at grand firs that were fairly large diameter, 18, 20 inches, that had all of the duff around them consumed and had just a frill of black bole right at the base. And when you peel away the bark at the base of those trees, the cambium is cooked, completely cooked. So that tree, although the crown is completely green, is a dead tree. So this is a photograph that I took at the mile marker 28 fire. So this burned on the Yakima Reservation in 2013. So we came out in the spring of 2014, and we're trying to evaluate some of these trees for their likelihood of survival. This tree on the left, this is a Douglas fir. It was infected with dwarf mistletoe. It had about 50% of what had been the live crown still left. The bole scorch was up to about 50 feet. The mistletoe brooms had been killed. So the tree was cleansed of dwarf mistletoe. So we went through the evaluation process, and then we're looking at the bole, and we went around 4 sides of the bole and just cut away a chunk like that of the bark. And I have a picture down there of one of those bark samples that we took away. And if you can see, the cambium there is brown. So although this was a fairly thick barked tree, about 18 inches in diameter, the cambium was cooked on that side. And we took 4 samples on 4 sides of the tree, and we found that 3 of them, the cambium had been cooked. So this tree had maybe a 75% chance of surviving its injuries. Now, if this were your tree, you could decide whether you wanted to leave that tree or not. There's not a big bark beetle population in this area, so that was not a risk. It was a late season fire, so that was not a risk. Pre-fire vigor was not that good, so you can walk through those different risk factors and add up the numbers that Don Scott has given us to try and see whether that tree is likely to survive or not. So do I have any questions? Comments? Yes?
I have 2 questions. First of all, when you talked about the, I guess it's, what do you call it, the pheromone?
Yes.
You didn't really mention mountain pine beetle. Are they just not really a player in this area because of elevation or something?
I'm glad you asked that question. Mountain pine beetles, of course, are a big actor in our forests, but they are not particularly attracted to fires. And so I did not mention them as one of the big actors after fire damage. It's not that they won't come in, but they don't respond the way some of the other beetles do.
Because I guess my question was, I do know that that pheromones have been used like on patches and through injection and stuff for the mountain pine beetle, and so I guess I was surprised that the western bark beetle doesn't respond to the pheromone treatments at all.
Western pine beetle and mountain pine beetle are totally different animals. They really are. The only thing that they have in common is that they both will attack ponderosa pine. But yes, so what Heidi has asked about is we do have a pheromone that is somewhat effective in limiting the attacks of mountain pine beetle in lodgepole pine. And we've also used it some in whitebark pine, and it does help. It reduces the number of mountain pine beetle attacks. It's not been a magic bullet, but it really has been quite helpful in the management of mountain pine beetles, but not western pine beetles. I've had some really sad results trying to use verbenone against western pine beetles. It just doesn't work. Yes, Dick?
I was wondering, in potential salvage sale, are these evaluations important on deciding whether or not a particular stand could be salvaged?
That's a good question too. So Dick wanted to know about the evaluation process and how would you use it. And the answer to that question is you would use it to meet your objectives. So if you're not planning to do any salvage at all, then it's really just academic. You could use it to try and make your best guess, and actually then that's an opportunity to see how effective it was. But it's all about percentages. You might say this tree has a 90% chance of surviving. That doesn't mean it won't die. Or it has a 20% chance of surviving. That's not zero. It might live. But so when I work with land managers, as I often do, to go through this process of evaluating the likelihood, different land managers have different objectives. Some managers don't want to cut any trees that might survive. Other land managers don't want to leave any trees that are likely to die. And really, you just set your sights on whatever your objective is, knowing that you're not going to be 100% accurate, whichever way you go. Yes, Heidi.
We realized, as the stewardship staff, when we were going out and looking at properties post-fire, that there was this real distinctive, like red, it looked like a fungus that was on the ground in areas that had burned. And so I guess I was hoping that would show up in your presentation, but do you know what that is?
Well, sometimes that mineralization will show up as a red, but this actually,
It's like a slime mold.
it's that slime mold. Yeah. There is a slime mold that shows up. It's not a factor in tree health, and I'm sorry that I don't know its name, but yeah, after the rain, it comes up. Yeah. And you'll often see it post-fire, and you'll see it on other kinds of dead material too. It's not a forest health factor, but it is kind of interesting and really colorful. Yes?
I have a question about the effect of insects. So we know, like, with less fire generally in our area, we have these denser stand conditions that are more susceptible to insects and pathogens. But once we have fires come through, the resulting stand structure, and I know this is variable, but in general, what would you say about the role of insects and pathogens post-fire and the kind of fires we now have generally compared to like historic times?
All right. Well, so there are some things that happen, for instance, on those landscape areas where all of the trees were burned. Those are going to be attractive to wood borers. They're not going to be that attractive to bark beetles, partly because it's going to be a long way for a beetle to fly to get into the middle of that stuff. So some bark beetles were killed by this fire, clearly. Their habitat was destroyed. So one thing that happens, as Susan was talking about ponderosa pine and trying to get ponderosa pine back on the landscape, we've eliminated a lot of Douglas firs. Douglas firs are more susceptible to dwarf mistletoes, more susceptible to a lot of our root diseases, and actually some of our defoliators, like Douglas fir tussock moth and western spruce budworm, those really feed on Douglas firs preferentially. They don't feed on the pines. And then once that kind of damage has occurred, then we get Douglas fir beetles coming into the weakened Douglas fir trees. So some of that is really changed now. And we're likely to get more pines back. Some of that will be from our planting. Some of that will be from Clark's Nutcrackers planting. So we have this opportunity now to, on those areas that burn, get a healthier stand structure. I don't know if did I answer your question?
No, you did, thank you.
Okay. Yes, Dick?
I was wondering, has there been any comparative studies on how insects affect forests that have not been actively managed versus those that are actively managed?
Well, we've certainly observed that kind of activity, and then, so we kind of get out of the fire regime then and into some of those other factors. So, mountain pine beetle, for instance, is, well, that's one of the best known host-pest interactions in forestry. And we know that lodgepole pine, when it gets to be a certain size and a certain age and it's dense, mountain pine beetles come in and kill them. So, so that's a well-known host-pest interaction in unmanaged forests. With Douglas fir beetle really responds. It responds to fire. It responds very aggressively to blowdown. And so, if blowdown is on the ground and it's fresh, Douglas fir beetles will come in. And if that blowdown is removed, then you have the opportunity to remove the Douglas fir beetles. If it's left on the ground, we can get really a huge pulse of Douglas fir beetle activity. We saw that happen in '97 in the northeastern corner of Washington and the Idaho Panhandle. There are parts of the Colville National Forest where it's hard to find a large Douglas fir now because of that Douglas fir beetle outbreak that followed a windstorm in that winter of '96, '97. I think we've got that kind of situation potentially building up in the Wenatchee River area right now after that blowdown in 2012. So those are the kinds of things where management versus no management, you might see different kinds of bark beetle interactions. Does that answer your question? Yes?
It's a little unrelated to insects directly, but you just mentioned, prior to Dick's question, your planting of pine. So is there a general plan, and have areas been chosen, and for what reason have they been chosen if they have for planting?
Actually, John can answer that better than I can.
Great, thank you.
Currently, we're the Battle Valley Ranger District. We're doing an assessment right now for our South Summit planting area. So that's one of the areas that was had the most extensive fire damage from the fire. So yeah, I've identified areas that we'd like to reforest. I think some of it plays into economics and access, because we probably have more areas where we can plant trees than we actually have seed to grow the seeds. So right now I've got about 7,000 acres that sort of tentatively identified as probably next summer, this coming summer, get out with more areas and just try and figure out
Is there a benefit to waiting a few years to let the things establish, not that the trees would establish, but in the sense of soils productivity and things like that?
Actually, my experience has been, the sooner you can plant trees, the better the trees you plant will survive, because there's less competition and moisture. But one of the things that I'm interested in seeing is, just seeing how many trees survive in some areas, because one of the things we noticed this past fall, western larch is an amazing tree where there were trees that they looked all scorched, and then several weeks after the fire was over, we started seeing new needles coming out on some of the trees. So I'm curious to see with ponderosa pines, sometimes their buds will actually survive fire. You get scorched where the needles are scorched. I've done this on my own property burning, and trees that were like scorched and clear to the top, but the buds actually survived the fire, so we actually was new needle growth. So one of the things with time is maybe you can find out just if there was some survival, and then if there was enough trees, maybe you only have to plant.
One last question, then we're gonna have to wrap it up.
Yes.
Walking up into the pine forest and like around the Bear Creek area, probably 2 weeks after the fires, maybe a little longer, 3, there was already very audible chewing happening in the trees, and I'm assuming those were the fire beetles that you mentioned. Would others come in as soon as that? I know you mentioned it, but.
Those are certainly the wood-boring beetles. And the larvae can get pretty large. They're much larger than the bark beetles, and they can get to be an inch or 2 in length. And the chewing is indeed quite audible. And I remember after the Pot Peak fire, going back there a couple of months later, and it almost looked like it was snowing, and that was the frass from the flat-headed borers, that excelsior just falling through the air. Yeah, they get very active, and the thing that they have going for them that the bark beetles don't, in terms of fire response, is that they will fly quite late in the season, and particularly the melanophila beetles and the horn-tailed wasps. Sorry, I didn't want to use the common name. Yeah, but they're active quite late in the season, and so they'll start chewing right away. August, September, you'll hear them.
Have studies been done on the impact of the three-toed woodpeckers following along in that succession of like the beetles coming in right after a fire, but then the woodpeckers come in quickly that are feeding off of those bark or wood borers?
I have trouble thinking there haven't been studies done, but I don't know of them. I know just from observation that you can see a lot of woodpecker response after fires. And woodpeckers actually are an important factor in keeping bark beetles under control, particularly the western pine beetle, because it tends to be, the larvae actually feed in the bark, so the woodpecker doesn't have to go all the way down into the phloem. They just have to scrape away the bark.